It is a non-recording thing.
Is that an oil filter wrench?
No, it's actually, and I have a picture of it here for its in use.
For putting your pencils on the wall.
So you can see it printed out. So I have a CPAP machine, one of those breathing machine things. So, and they have water, so it like humidifies it so you don't get all dried out. So you kind of want the tube to be higher than the machine. That way you don't have water that kind of flows down into your nose. So you kind of want the tube coming out of the machine to kind of go up onto something and then drop down to your level. So you kind of have this thing where the tube hangs. Plus it just manages the tube a little better. So this part right here, by my bed has, we have like some drawer stuff up on this big hutch. And so that pops onto the drawer and then drops down into the smaller spot. See? So you put the knob for the drawer here, and then when you let go of it, this sneaks back behind it, so it locks in. And then you fish your tube through this guy, and then it controls it. So I designed that last night and printed it. It took about 3 hours to print, and worked great. Isn't 3D printing awesome?
Yeah.
We just ordered a CNC machine.
Really?
Yeah, so we got a small one, but big enough to print some of the extra parts, and then we're gonna 3D print a gigantic CNC machine. So we can carve out 8-foot 8x4 sheets of metal.
Oh, so a CNC router?
Yeah, CNC router. Yeah.
I was thinking like a CNC lathe, and I'm like, what do you need that for?
No, router. Sorry. But these are all 3-axis. But I want to go and get a 5 or a 6-axis. But I think we could do some of that with a robotic arm already. So, yeah. But this will be interesting. So we got one that should be coming in tomorrow to play with, or possibly cut a finger off. Either one.
Small request. Can we get Cura or some other slicer on a machine that actually has a graphics card?
Sure. It's on that Mac in that room, which you can log into with. It's also on the Omen that's in that room.
Is it now? Okay.
I believe so.
All right. Wasn't last time.
Yeah.
So.
But also now with the machines are all wireless. So do I have it on here? So there you go. You got 12 machines. Now, and if you want to print something, here we'll just do a quick. Somebody will get my cross. There, something's printing. So in 11 minutes, my 3D printed cross will be done, and somebody can go down and get it.
I'll go get it.
Blaine can be the sprinter, the runner. But yeah, I mean, isn't that awesome? That we have 12 printers all online that we can just send stuff to.
I gotta figure out what's wrong.
What's G code?
G code is like when you go into Cura, this guy. Yeah, so there's my part from last night. So I designed it in Tinkercad, and then I brought it in here to Cura, and you put your settings. So I printed it at low quality, and just need to be kind of a draft thing. And then when you slice it, it creates a G code file. So G code describes all the positions. It's a CNC type thing. It describes all the positions that the tool, in this case, an extruder, has to move in order to do this on the X, Y, and the Z. So the Z, it's levels. Yeah.
Does Kira have an auto smooth feature, or do you just have to add more vertices to your objects?
I don't know the answer to that. Yeah, I mean, obviously your knowledge of 3D modeling stuff
I
is
just haven't used Kira, and I know that's
super superior to mine. But this is pretty good design for me.
Yeah.
Is what I'm getting at. And I made this in Tinkercad in 10 minutes.
Okay.
So it's, I'm going to approach things much more from an engineering functional perspective where you can actually make things look good. That is not in my wheelhouse. Not even close. Although I think this looks pretty legit. I was pretty.
You could sell them.
That's what I was thinking. This is something people need.
Yeah.
Like legit. So yeah, I mean, I think you really could sell something like this. So we're gonna maybe start doing that. Come up with custom designs, get an Amazon channel, and just start selling stuff on Amazon and on eBay.
You could patent the design too, and then no one can steal it.
Well, I don't know if I need to go that far. I do well. I have an uncle who's a patent attorney. Yeah, if you go to
See?
yeah, if you go to littmanlaw.com. That's my
Oh, yeah, you mentioned
that's
that
my Uncle Richie.
before.
My dad has 7. He's one of 7 brothers, and they're all doctors and lawyers. Which makes it very funny, given that I came from a Jewish family. The stereotypes are pretty true. So I probably can get a free patent, is what I'm saying. But otherwise, patents are pretty costly. But yeah, so this guy, when you slice a 3D object, it turns into G code, and it starts off as an STL. So if I clear this, clear the build plate here and just come down, I think my yeah. So this is what I originally designed. So it showed up like that on there, but if I printed it like this, it would have put filler all in this part here as a support, because it wouldn't have been able to print this top part of it without that support, or it would have gotten kind of droopy or something. So that's why I rotated it. And then I just had a little bit of fill in here for it to kind of support it. It was easier to build it up like that. But yeah, home design. Awesome. I mean, that's just, I'm thinking pure talent, but I might be thinking wrong. I'm not sure, but it felt pretty good to me. And we even did a little 8-minute prototype thing of it where we printed out just this part of it in a single layer. Took about 8 minutes just to make sure that it was going to fit over the knob that we wanted to print it on, you know, before I spent 3 hours printing something that wasn't going to fit. So I thought it was pretty good.
Wait just a moment. Can you go back to the site with all the printers?
Somebody at least is doing something with this one, but nothing's printing on it. Oh, you just want the
Yeah.
IP? We're going to be adding user accounts, but for right now, if you know what you're doing with 3D printers, feel free to print stuff on there. Do know that right now we don't have it set for it to tell you when it's running out of filament. And since we are getting cameras and stuff put on there, there is a legitimate chance we might have to restart the server, which might end your print. But feel free to use it so we can start beta testing it, whatever. So it's 172, 31, 224, 162, and it's port 3344. And there's 12 printers that you can print to. And then we will have cameras set up, but the way it'll work is the cameras, it looks like, because we've run out of unique IRQs for USB devices, we can only have 6 cameras with 12 printers. Because I think each camera takes up 2 IRQs, one for audio, one for video. And then like things like the Wi-Fi card and stuff like that adds up. So I think there's 32 unique IRQs that you can have on the system. So we can't have more than 6 cameras with 12 printers. So what we're going to do is we're going to have, we're building a PVC thing where the cameras are going to be kind of above 2 printers. So you'd be looking down at both trays. And the reality is the cameras are kind of cool to sit there and watch you know, the thing actually print, but the real functional use of the cameras is to go on here and say, oh, there's nothing print. Oh, there is something printing. There's a pumpkin vase printing. Is that one of you guys, or is that okay? So the idea would be I would come in here, I would click on the webcam, and this might not necessarily be the webcam that's on that printer, but it might actually be. We'll see. But it'll show you what's going there. But you would be able to see if a printer said it wasn't currently being used. You would be able to see if the last person left their print sitting on there, because you don't want to print on, you know, it'll be bad. Unless I did see a video one time of kind of a things to throw in the front of your G-code file that basically just did a sweep, you know, just bowled over whatever is currently there to clear the plate. And then they basically had like this funnel off the front of it that just dropped everything into like a little bucket. So you can just keep printing over and over again with a self-clearing G-code template. So I thought that was kind of.
How often does that break the print?
Well, I mean, I think you kind of cushion the landing zone, yeah. But yeah, I mean, it's probably not wise because you don't necessarily know the fragility of what was just printed, right? Like I'm guessing that parts of my little CPAP holder thing wouldn't necessarily live with a fairly hard drop to a hard floor just because maybe it would have just chipped off the corners or something. It probably would have still been functional. But some things are pretty weak. All right, so today we are looking at adding lambdas to our var environment. Okay, so what is a lambda? So we were supposed to read this for today, right? There's some stuff from the book we were going to read. So let's kind of think about what is a lambda. So we start off with the high level thing. This is an unnamed function. All right, that's what it is. Okay, well, what are the parts of a function? What are the parts of a lambda?
Lambda.
Okay, well, that's the word. But is that a functional part?
No.
Yeah, it has no function other than just to identify it as a lambda, right? All right, so what are the functional parts of a lambda? Go ahead. Parameter list. All right, so we have the param list. So this is the binding of vars part. What else do we have? The body. Yeah, body of it. So the function part is not incorrect. So function part, maybe we say logic part, something like that. Maybe we call this guy the body of the function. So if you think about this in terms of Java, the stuff that's in between the opening, closing curly braces, where our parameter list is the stuff that's in between the parentheses up at the top. All right, and just like in Java, if I just kick over, hopefully I have something on my Java screen here. All right, closed Eclipse? Oh, whatever, doesn't matter. Well, let's open it again real quick just so I can show you this. We can connect the dots here to a language that we're very familiar with. So here's a function. Its name is count spaces, so that's what we're trying to accomplish. We're trying to accomplish the part where we can actually name a function rather than it be an unnamed function. Make sense? That's what we're trying to invent. So what's the real pieces of a function? This would be Java's version of a lambda. We have a list of parameters that can contain 0 or more things. And then we have the body. Make sense? Okay. Now, if we look at scheme, this is how we define a lambda, name a lambda. This guy right here, that is an unnamed expression. How do we give a name to a value? We use define and give it the variable name. Now we have something called fizzbuzz. Make sense? All right, so we're trying to accomplish, this is the scheme version of what we just looked at in Java. This is what we're trying to accomplish in our variable environment. All right, so this is what a lambda is. Now, what happens when we add a literal to our environment? So let's say I do something like, what do we call ours? Remember? So remember A is 5, right? So that goes into our variable environment and it associates a symbol A with the value 5, okay? Now, this would actually be, actually not bar. I know it's called lit expressions or whatever, but let me not put exp on there. Okay, so we have a remember A is equal to a lit expression 5. So in my environment, I would have an extend env with a, what does this guy look like? Extend env a5 on the empty env, something like that. That's what my environment would now look like. Make sense? How did I get the 5 from that? In my interpreter, how did I get the 5 from that? I applied that expression. I executed the expression, right? If we go in and we look up a question in here. Here's my remember expression. So we're going to extend our environment with the symbol by, and what's its value going to be? It's going to be whatever apply expression returns on the body with the, or the value associated with this variable in the current environment. And what environment are we extending? The current environment. So apply expression here, that guy is the guy that boils down, in my example back here, lit expression into its value, which is just a number. Make sense? Now, if I don't do anything else, if I just say, remember, B is a lambda x var exp, well, now I'm just mixing and matching, huh? So let's just keep it like this. Var x. If I want to remember that lambda expression, how would I extend my environment? So effectively, I'm adding the type of value I know how to remember, correct? Right now, in our current implementation, we only know how to remember lit expressions, numbers. And our lit expressions are limited to numbers, right? That's all I know how to remember is numbers. So now I want to remember a lambda. Now right now what I'm saying is whenever I have a remember statement, I extend my environment with that symbol, that variable name, and whatever apply expression boils down to for that guy. The resolved value of that expression. What do I want my extend env be onto? Well, let's just pretend like this was the first line just so I don't have, what's the value that should go here onto my empty env? Solve for question mark.
We don't want to resolve it with apply expression because then it will give us the result of that, but that's not what we want. We want to store the function, so that's not right.
Well, let me ask you this question. What would apply exp Ninja? Return for this.
Should just be false.
All right, let's go look. If we're looking at a lambda expression calls apply expression on the body, right? And the body of that guy is this dude right here. And what will that boil down to? You mentioned false. Why false?
Because we haven't defined x in our
Yeah.
environment.
It's going to try to look in our environment for a variable named x to get its value. It's not going to find it. Right? So this is going to set b equal to false. Is that what we want to do
No.
when we store a lambda? Yeah, we don't want that guy to boil down, do we? We kind of like, look, I'm saving you for later, right? I'm going to need you later because when am I going to use a lambda? What kind of expression do we use lambdas in?
Apply expressions.
Who?
Apply expressions or
App expressions, yeah. So I was going to say cat, dog, or app expression, right? That's my usual go-to move. All right, so it's an app expression. We use it in a list containing an expression followed by, I think we support 0 or more parameters now, right? So followed by 0 or more other things. Okay, so we want to actually store this lambda unapplied. That way I can apply it later. So I want this guy one way or another. Just going to put it in there for right now, like that. So that later on I can do something like B3. Actually, it would, if I was writing this out as an expression, this would be a var expression B, passing it the lit expression 3. I want to be able to do that. I want it to resolve. So if you remember back several classes, this guy, actually I still don't have it written, right? This is an app exp. So there's an app expression that takes in 2 parameters. Well, it takes in at least 1 parameter. And then, so it takes in this guy right here. What do we assume that guy always is?
lambda.
He ultimately will boil down to a lambda. At this point right now, we assume he is a lambda. We don't boil him down to anything, right? So we can actually pass that a lambda. Is that how, can I apply a lambda directly to a value? Does that work in Scheme? Can I write something in Scheme like this? Can I say, let me get rid of that part there. Can I say lambda x and then pass it a 5 like that? Will that work in Scheme?
Yeah.
Yeah, that's effectively an app expression, right? I'm going to set 5. 5 is going to get passed in for the x, and this is going to boil down to a 5. Make sense? Or I could define B to be a lambda that takes in an x and boils down to x, and then say B to 5, giving me a 5. Make sense? I don't have to store it in a variable, but it's handy to store it in a variable because now I can say B7 or B2. Make sense? So I can apply a lambda directly. So a lambda is an unnamed function. This is an app expression effectively. This is Scheme's version of an app expression. And it's saying, take this lambda and apply it to this input. That make sense? If I want to have more than one input, still works. So I can come in here and I can say x, y, and then maybe do plus x, y, and then pass it a 5 and a 7. That gives me my 12. All right, so everybody gets that we don't need to store a lambda in a variable in order to use a lambda. But if I want to use this function a second time, I got to write the whole function again. Mm-hmm. So I got to steal all this, come down here, change my inputs, 14, 71. Oh, I missed my opening parenthesis. Didn't quite copy enough. Need one more opening parenthesis. There we go. And there's my sum of those guys. That's not all that handy. Because now every single time I want to apply a function to some inputs, I have to rewrite the entire function. If we go back to Java here, why did I name this guy count spaces? So whenever I want to count spaces, I can call something called count spaces. I didn't have to redefine this entire function every single time I wanted to do something. Make sense? That's why it's handy to have lambda stored in our environment. Okay, so now we've seen the example of that. What was that, the very last question on the exam? Okay. So we'd like to be able to define a variable name, set it equal to a lambda, so that later on I can apply the lambda stored in this variable to this input. The lambda stored in that same variable to a different input. The lambda stored in that same variable to a different input, so on and so forth. All right, so everybody get what we're trying to accomplish here? Okay, so question is then, how do I make sure that if I'm storing a lambda, I don't try to resolve it?
We can check to see if we're trying to remember lambdas inside of our remember.
Okay, so if we come into our code up here, so here's my remember. Well, where's my remember?
I think it's higher. Top of 190.
All right, help me find my lambda.
190.
You have one line to look at. That is not going to work. All right, so here's my remember. So my remember, I get the variable name. Is that going to change if I'm remembering lambdas? Variable name's a variable name. A, B, count spaces, doesn't matter. Okay, so that guy stays the same. Is my value here going to change from that line? No, I'm still extracting the value. What's going to change is whether or not I do something with that. Make sense? All right. So right now I'm just saying, oh, I'm doing something with it. that dude's going to extend my environment, hands down. But I can ask the question, if what I'm looking at, if value is a lambda. How do I ask if value is a lambda?
Lambda question mark, EXPR.
Yep. So if, did I just call it, so I call it lambda exp question mark like that?
Yeah.
Is that it?
Yep.
Nay, let's both admit you're better at spelling these things than I am. I basically make up the function names every single time. That's why we have Blaine in charge of this, which we're probably now operating at around a C- or something like that, really, for the number of errors he
I'm letting
catches.
other people participate.
Huh? Oh, you're trying to support the rest of their education?
He's outsourcing.
There was that. Do you remember in the news several years ago? What's your opinion of this? There was some guy that was he was a consultant and he was getting paid, I don't know, $200,000 a year or something like that, and he was outsourcing his work to India or something like that. All his work was getting done. Okay, it was getting done. Everything was good. Bosses were happy. This guy was, I think, still clearing like 120 grand a year. So he was getting 120 grand a year. He was getting paid 200, paying 80, keeping 120, outsourcing all his work to India. And he got fired.
Yeah, because then they could just pay the guy in India.
Then we still had to manage that. This guy was having to manage. I mean, I think he had a team in India. You know, he was, and I don't think he was always outsourcing to the same people. Depending on what project he was working on, he had to go to the. Is that interesting though? Yeah, he got fired. They said that he was, I don't know, unethical. Yeah, something like that. It's like, look, you told me to do this work. Work got done. Doesn't matter how I got it done. Well, I mean, I guess within reason. It's like you don't want to start like offing people.
Look,
It's like I need you to convince this company to accept our offer.
look, you said prevent their competition from eating into our profits. Now they can't eat anything.
I say to you, what competition? But Frank, we're in the pencil business. No, we are the pencil business. All right. So,
Actually,
How do you make a pencil disappear?
is this how I spell it?
yeah.
All right. So if lambda exp, if value is that guy. So if I'm looking at one of those, I need to do one thing. So I'm just going to put in, we're going to say Say do something. There we go. Actually, I could just, can I quote the whole thing? If I quote the whole thing, I don't need that, right? All right, so that's what I'm going to do if it is a lambda. We're going to have to solve that. Else, what do? I do this stuff. Just steal that for a second. So that's my else. That ends the if. That ends the let. That ends my remember. Okay, so now what's this do something? That means value is a lambda expression. What do I store? Do I store the entire expression?
Yes.
Could. Because later on, when I resolve it, when I resolve a value from my environment, I need to be able to identify what kind of value I'm looking at. Am I looking at an already resolved value, or am I looking at a lambda, an unresolved lambda? Now, could we just choose not to resolve anything and store every value as its unresolved expression?
You could, but isn't that a little inefficient because then it has to go back through?
Possibly. Inefficient would be, so if I needed to get the value 5 20 times, I would be applying expression on a lit expression 20 times to squeeze out the 5 20 times instead of doing it once and then just having a 5. Now, what if we had a math formula in there? Because we're probably moving, if we think about the difference between like a let and a let star, we might want to say, plus AB as a value we're storing. And what we really want is we want the value then at that point in time. Because later on, the value of A and or B could be different. And when we create a variable, if we say C is equal to plus AB, we want C to be equal to the value of A and B added together now, right? Not added together the next time we ask for this variable, followed by the next time we ask for C, followed by the next time we ask for C, where A and B might have been updated in between, right? So when it comes to most expressions, we want the answer. Yeah.
Well, since this is an interpreter, wouldn't it be okay to have it boiled down to its value now? Because as a compiler, it does it all at runtime.
Well, but it's not. So here, if we go into Java, and I say int b is equal to count plus 1, like that. And then let's say in here I do a system.out.println b. What value do I want b to actually be? Do I want it to always be a 1? Or do I want b to be a 1? Next time when count goes up, it's a 2. When count goes up, it's a 3. When count goes up, it's a 4. When I print out b here, I'm relying on b being its original value, which means what is the current value of count that got resolved to a 0? 0 plus 1 is 1. B is equal to 1. From this point forward, I never change b again. So every single time I hit this line, I'm printing out a 1. Even though b was defined in terms of this variable count, and count might change. Make sense?
I don't know how that relates.
Well, you said since it's an interpreter, wouldn't it work one way as opposed to a compiler? This is a compiler. This is a compiled language. And you mentioned compilers do it at runtime, or do it at compile time, rather. Okay? So you're saying that this was an interpreted language, we would handle this, you seem to imply we would handle it differently in an interpreted language than we would in a compiled language.
I just wasn't sure if in our scheme program, are we running, do we want the boiled down value?
Well, we get to invent the language, so we can decide if we want the boiled down value or not. But as programmers, when we define a variable and give it a value, what do we intend the value of b to be? Do we intend the value of b to be kind of functional, where whenever I call this guy, I get his value calculated then? Or do I intend b to be the current value of count plus 1? Traditional languages say that's the current value of count plus 1. If I wanted it to be something else, I would maybe have a function that gave me the current value of count plus 1, and then b would be, well, I'd have a, I would have a function called b in that case, where it returned for me the addition of whatever count is plus 1. So that way it was always giving me the current version of count plus 1. So that's me using a lambda. Execute it later. Makes sense? So as programmers, we are always assuming that when we define a variable, we're getting a solid value associated with it. If it is not a function, so in this case, if I'm defining a variable called count spaces, I want this guy to be stored in general form. That way I can call it again, right? He's not a resolvable value. But whenever I have a value that is resolvable, when we define variables, I want it resolved. That's what we usually assume from a language. Would it be illegal for me to have a language that doesn't do that? No, that'd be legal. It might be kind of hard to program in that language, though. Be fairly error prone in case you, define, especially if you're switching between languages and you're kind of taking programming as a skill set along with you. You might run into some situations where, like, I thought this was going to be 1. When it's actually a 2, then a 3, then a 4, then a 5, then a 6, depending on how many spaces you bumped into. All right, so does that make some sense? So it doesn't matter whether we're dealing with an interpreted or a compiled language. I think I don't need this code anymore. I'll just leave it in there. It doesn't matter whether we're dealing with an interpreted or a compiled language. The way we would define variables is going to be basically the same. We want to have the value of the variable to be its current value if the value is resolvable. Otherwise, the value is not resolvable. That means it's an expression we plan on applying later. And we want to store it as such. Okay? So, what am I actually going to do here? I'm going to extend. Now, let's look at what extend env does. Extend env, does it call anything on that value? Here's extend env. We take a name and a value, and we just create a list out of that name, the value, and the environment. So it's not doing anything special to that guy. So whatever I hand him as far as the value goes, that's what he's using. So I should be able to... I'm lost. Who?
199.
199? Ha! Nailed it. So I should be able to call extend env. Passing it whatever my symbol is, and then passing it my unapplied value in the current environment. Make sense? So now I have placed lambdas into my environment. But can I now use lambdas in my environment? What does an app expression do right now? An app expression, here's my else, it gets my here's my operands for that. So my operator, this allows me to extract the lambda. So we assume that this operator here is effectively a lambda. So we can call this guy operator is assumed to be a lambda. Right? But I might not have a lambda there. I might have a var expression. And if it's a var expression, what do I need to do? I need to go get the lambda associated with that var expression. That make sense? So I want to be able to add to my language. Let's get rid of this stuff down here. I want to be able to do something like remember expression A to be a lambda exp, which takes in, we have a list of parameters now, right? So this is going to take in a C, and it should boil down to a var exp C. So I'm going to remember A to be that lambda. Then I'm going to have a block expression. Oh, this is my example where I had a block expression inside of a block expression. I'm going to go ahead and actually take that out for this example for me to give you some code to work with. So then I'm going to create an app expression, but instead of this first part being this guy, it's going to be a var exp A, and I'm applying it to a lit expression 5. So I want to be able to remember a variable A being equal to a lambda expression. Then I want to be able to, actually, to fully test this, we can also say remember expression B to be a lit expression 5. And then we'll call this guy a var expression B. So I want to be able to remember my function in a variable named A, my lit expression 5 in a variable named B, so that should actually boil down to a 5. Then I want to be able to call an app expression, passing it a var expression A, which should boil down to the lambda, along with the value of B for my environment. And this should give me, in this particular case, the answer should be 5, right? Boils down to 5, which is passing a 5 in as a parameter to this lambda. So 5 would come in as C, and then we just boil down to the value of C, which should be 5. Make sense? So what you need to do for your homework is extend our current interpreter to support that. Make that code work. Right now it won't. Make sense? Questions, comments, concerns, bribes. I will see everybody on Friday. Remember, tonight is the next Tech Talk. Okay, and we're having filet mignon lobster tail? I think so, yeah. Medium rare. If you need it cooked more well done than that, just let him know. Let Eric know. All right.
We got
And tonight is the CEO of Tesh Global.